holes and joists are considered bundling under NEC section 310.15b2. When electrical cables pass through these holes, specific guidelines must be followed to ensure safety and compliance with the National Electrical Code. The primary concern with bundling cables is the potential for heat buildup. When multiple cables are grouped together, the heat generated by each cable can accumulate, leading to higher operating temperatures. These elevated temperatures can degrade the insulation of the cables, reducing their lifespan and potentially creating a fire hazard. To address this issue, the NEC requires that bundled cables be derated, which means their ampacity, or current carrying capacity, must be reduced. The NEC considers cables bundled when they are installed in contact with each other for a distance of 24 inches or more. This rule applies even if the cables are not directly touching but are close enough that their heat dissipation is affected. When cables run through the same hole or opening in a joist, they are generally considered bundled regardless of whether they maintain spacing, given that they are within that 24-inch proximity. The derating factor is applied to compensate for the reduced ability of the cables to dissipate heat. Specifically, the NEC mandates that bundled cables be derated by 20%. This means that the maximum allowable current for each cable must be reduced by 20%. This derating applies to all types of cables, regardless of their size or insulation type. To properly derate cables running through joist holes, there are several steps to follow. Firstly, determine the appropriate ampacity for the cables based on their size and insulation type, consulting NEC Table 310.16, which provides ampacity values for various conductor sizes and insulation types under specific conditions. These values are based on an ambient temperature of 30 degrees Celsius or 86 degrees Fahrenheit. If the ambient temperature is higher, additional derating may be required. Secondly, identify all cables that are bundled together, focusing on those running through the same holes or openings in joists. If the cables are within 24 inches of each other, they are considered bundled. Thirdly, apply the 20% derating factor to the ampacity of each bundled cable. To do this, multiply the ampacity value from NEC Table 310.16 by 0.8. The resulting value is the derated ampacity for the cable. For example, if a 12 American wire gauge copper cable with THHN insulation has an ampacity of 30 amps according to NEC Table 310.16 and it is bundled with other cables in a joist hole, the derated ampacity would be 30 amps multiplied by 0.8, which equals 24 amps. It is crucial to ensure that the overcurrent protection device, such as a circuit breaker or fuse, is properly sized to protect the derated cable. The overcurrent protection device should not exceed the derated ampacity of the cable. In the previous example, a 20 amp circuit breaker would be appropriate for the derated 12 American wire gauge cable. If the calculated derated ampacity does not correspond to a standard overcurrent protection device size, the next lower standard size should be used, in accordance with NEC section 240.4b. In addition to derating for bundling, it is also important to consider other factors that may affect the ampacity of cables, such as ambient temperature and the number of current carrying conductors in a raceway or cable. If the ambient temperature is higher than 30 degrees Celsius, a temperature correction factor must be applied, as specified in NEC Table 310.15 bone. Similarly, if there are more than 3 current carrying conductors in a raceway or cable, an adjustment factor must be applied, as specified in NEC Table 310.15 cone. These adjustment factors further reduce the allowable ampacity of the cables to prevent overheating. The NEC provides several examples and guidelines for calculating ampacity derating and adjustments. It is essential to consult the latest edition of the NEC and any applicable local codes to ensure compliance. Proper documentation of ampacity calculations and derating factors is also important for future reference and inspections. There are several practical considerations to keep in mind when running cables through joist holes. Firstly, use appropriately sized holes to minimize the number of cables passing through each hole. This can help reduce the amount of bundling and the need for derating. Secondly, maintain as much spacing as possible between cables within the holes. While this may not always be feasible, Any additional spacing can help improve heat dissipation. Thirdly, consider using cable ties or other means to secure the cables within the holes, preventing them from shifting and potentially increasing the amount of bundling. In some cases, it may be necessary to use larger conductors to compensate for the derating. For example, if a 14 American wire gauge cable is initially selected for a particular application, but the derating requirements reduce its ampacity below the required level, it may be necessary to use a 12 American wire gauge cable instead. Using larger conductors can increase the cost of the installation, but it can also improve the overall safety and reliability of the electrical system. Another option is to use cables with higher temperature ratings. Cables with higher temperature ratings are designed to operate at higher temperatures without degrading. These cables can often be used without derating, even when bundled, provided that the terminations and equipment they are connected to are also rated for the higher temperature. However, it is important to verify that the use of higher temperature cables is permitted by the NEC and any applicable local codes. In some situations, it may be possible to avoid bundling altogether by using a different wiring method. For example, instead of running cables through joist holes, it may be possible to run them along the surface of the joists or through a conduit. These alternative wiring methods can eliminate the need for derating and simplify the installation process. When performing electrical work, it is always important to follow safe work practices. Firstly, to energize the circuit before working on any electrical components. Secondly, use appropriate personal protective equipment such as gloves and safety glasses. Thirdly, inspect all tools and equipment before use to ensure that they are in good working condition. In summary, running cables through joist holes requires careful consideration of the NEC requirements for bundling and derating. By following the steps outlined above and consulting the NEC, it is possible to ensure that the electrical installation is safe, reliable, and compliant with all applicable codes and standards. Firstly, determine the cable ampacity from NEC Table 310.16. Secondly, identify bundled cables within 24 inches. Thirdly, apply a 20% derating factor. Fourthly, size the overcurrent protection device accordingly. Always consult the latest edition of the NEC and follow safe work practices. This information is intended for general guidance only. Always consult with a qualified electrician for specific applications and ensure compliance with all applicable codes and regulations.